Have you ever opened up your GCSE computer science exam, seen one of those draw the logic circuit questions and just frozen? Yeah, you're not the only one. But today we're going to crack the code on a classic example. I'll give you a foolproof method that turns any Boolean expression into a perfect diagram. Let's dive in. So, picture this. You're in the exam hall, you'll flip the page, and this is staring back at you. Question 5b. It's asking for a logic circuit for the expression P equals not A and, in bracket, B or C. Now, it's only a 3-mark question, but it can look pretty intimidating, right? The key is not to panic. You just need a system.
And that system starts right here. Step 1, we've got to decode the expression. Before we even think about drawing, we have to understand exactly what the expression is telling us to do. We're going to break it down into simple, manageable pieces using the good old order of operations.
Okay, so just like in math, Boolean logic has its own order of operations. And the golden rule is super simple. Always start with what's inside the brackets. That's our way in.
So this gives us a crystal clear 3-step game plan. First, we tackle the brackets. That's the B or C part. Second, we handle the not A. And finally, we combine the results of those two parts with the AND operator. See? This simple little roadmap is going to guide our entire drawing process.
All right, on to step 2, building the circuit. We're going to take that plan we just made and turn it into an actual diagram. We're going from an abstract expression to a concrete logic circuit, one gate at a time. This is where it all comes to life. Just a super quick refresher before we start drawing. What's a logic gate? Well, it's just a building block of a digital circuit. You can think of it as a tiny decision maker. Most of them, like AND and OR, take 2 inputs and then spit out a single output based on a very specific rule. Every single logic circuit has to start with its inputs. In our expression, P equals not A and B or C, we've got 3 variables, right? A, B, and C. So we're going to start by drawing 3 lines on the left-hand side of our diagram, one for each of those inputs. Simple as that. Now, let's put our plan into action. Step 1 was solving the brackets, B or C. To do that, we take the lines for our inputs, B and C, and we feed them straight into an OR gate. You'll know it's an OR gate because of its distinctive curved input side. Step 2 on our list was dealing with not A. So we'll take the line from input A and pass it right through a NOT gate. This gate's a bit special. It only ever has one input. You draw it as a triangle with a little circle at the point, and that circle is what signifies the inversion, the NOT.
And here we are, the final step of our build. We're going to take the output from our not A gate and the output from our B or C gate, and these 2 lines now become the inputs for our final gate, the AND gate. The AND gate is easy to spot. It's the one drawn with a flat back and a D-shaped curve on the front.
And there it is, the completed circuit. You can see our 3 inputs, A, B, and C, over on the left. You can see the NOT gate on A, the OR gate for B and C, and how both of their outputs feed into that final AND gate to give us our result P. It's a perfect visual representation of our original expression. Okay, so we've drawn our circuit. It looks right, it feels right, but how do we know we've actually secured all 3 marks? Well, let's move on to what's probably the most important part for any exam, checking our work against the official OCR mark scheme.
This is exactly how the examiner is going to award the points. Check it out. You get 1 mark for correctly drawing not A, that's our triangle gate hooked up to input A. You get a 2nd mark for correctly drawing B or C, that's our curved gate connected to inputs B and C. And that final 3rd mark, that's for the AND gate with 2 inputs, our D-shaped gate, correctly taking its inputs from the other 2 gates. Boom, we've hit all 3 points.
And hey, you really need to pay close attention to this note right from the mark scheme. It says you can get a maximum of 2 marks if the circuit isn't logically correct, or, and this is key, if you have any additional or missing gates. This is why being precise is so important. Don't add extra stuff you don't need. Just draw exactly what the expression asks for.
So at the end of the day, this isn't just about this one question. It's about having a repeatable method, a way to decode, plan, and then draw that you can apply to any Boolean expression they throw at you. Now that you have this systematic approach, what other circuits can you build? Give it some practice, and trust me, these questions will start to feel like easy marks on your exam.